All right, well, welcome to this year's Hall of Fame. It's my privilege to serve this year as Interim Dean of the College of Engineering at the University of Illinois at Urbana-Champaign, and to welcome you to the 2012 induction ceremony for the Engineering at Illinois Hall of Fame. In 1870, Stillman Robinson, the university's first engineering professor and later the Dean of Engineering, instituted an engineering curriculum at Illinois that combined science-based lectures with experimental laboratory practice. Since that time, technical excellence has been the hallmark of engineering at Illinois, whose alumni have shaped the modern technology and have built a significant portion of the world's infrastructure. Illinois engineers have in many ways created the world in which we live. Today we live in a challenging time, but one that provides great opportunities for engineers to make a difference in areas such as energy, sustainability, transportation, human health, agriculture, and many others. Engineers are striving to change and improve the life for all on our planet. Those who molded the history of engineering at Illinois live on through the generations because of their accomplishments, their contributions, and indeed their legacy. Today we celebrate those who lead with integrity, who have changed our lives, and who are exemplary individuals dedicated to making a difference tomorrow, today, and for many tomorrows to come. Just as the central Illinois farmland is some of the most fertile and richest in our country, engineering at Illinois provides one of the most fertile environments for creativity, innovation, and leadership. It's time that we break out of our Midwestern modesty and let the world know of the life-changing innovations that begin right here at Illinois. It's time that we embrace our Midwestern work ethic and demonstrate the fruits of our labor as the University Crest proclaims learning and labor. Today we surround ourselves with greatness. We celebrate exceptional accomplishments, exceptional engineers, scientists, entrepreneurs, and most of all, leaders. We honor extraordinary individuals dedicated to making an impact, a societal impact, a global impact, and a personal impact. The Engineering at Illinois Hall of Fame will always tell the story of how we at Illinois are transforming the world one generation at a time, building a brighter, indeed brilliant future. So thank you very much for coming. I'd first like to introduce Chancellor Wise, who's going to speak. It's my pleasure then to introduce our Chancellor, Phyllis Wise. She's President and Chancellor at the University of Illinois at Urbana-Champaign. As Vice President and Chancellor, Dr. Wise is the Chief Executive Officer for the Urbana-Champaign campus and is responsible for all the financial programs, campus policies, priorities, and the mission of ensuring a transformative educational experience for America's next generation of leaders. Prior to this appointment, she was interim president of the University of Washington. Before that, she served as executive vice president and provost at the University of Washington, a position she held for 5 years. During that time, Dr. Wise was a professor of physiology, biophysics, biology, obstetrics, and gynecology at the University of Washington. She also served as Dean of the College of Biological Sciences at the University of California, Davis. She's a fellow of the American Association for the Advancement of Science and a member of the National Academy of Sciences Institute of Medicine. Chancellor Wise continues an active research program in issues concerning women's health and gender-based biology. Please help me welcome Chancellor Wise.
Thank you, Dean Bragg. It's a real pleasure and honor to be here this evening. This is such a wonderful occasion. And I too want to extend my welcome to all of you. Last year, when I first got here, this was one of the first occasions that I had a chance to be at and realized just how many wonderful people have been affiliated with the College of Engineering. Illustrious people who have contributed so much. And tonight we induct 8 incredible individuals into the Engineering Hall of Fame, which really has only existed since 2010, one of whom we honor posthumously. On behalf of the University of Illinois at Urbana-Champaign, I want to offer my congratulations and my gratitude to each of you inductees. Individually and collectively, you've truly changed the world. From an institutional perspective, these Hall of Fame engineers are almost unmatched in terms of achievement in the College of Engineering and to the rich history of innovation, which this college is known so well for. These inductees also create the benchmark for the future and they make sure that we all strive to be like them. The next Charles Henrys, the next Sohaib Abbasis, the next Steve Samples. The world outside our walls consider their work exceptional and visionary. But those of us on this campus, we consider their accomplishments to be the bar by which we measure everyone else in the future. This group of inductees is proof that our professors, that our students, and that our graduates anticipate the future before it arrives, before many people even imagine that it could be part of the future. These 8 individuals represent the transformational education one receives at the College of Engineering and at the University of Illinois at Urbana-Champaign. Please join me in saluting these 2012 inductees. It's now my pleasure to introduce an individual who knows firsthand just what a tremendous impact this campus can have, both from an individual perspective and globally. Please join me in welcoming President Robert Easter.
Thank you, Chancellor Wise. It's always a pleasure to come to the College of Engineering, and it's a special pleasure to be here this evening to be a part of this event, to induct this 3rd class of distinguished individuals into our Hall of Fame, Engineering Hall of Fame. Across Illinois, from Chicago to Cairo, there are countless points of pride that every citizen of our great state can share. We're a global hub of commerce, home to more than 30 Fortune 500 companies. 11 are in the top 12, including industry giants such as Archer-Daniels-Midland, Walgreens, Boeing, State Farm, Caterpillar, Kraft, Abbott, the list goes on. We're home to Chicago, the nation's 3rd largest city, and a magnet that draws over 50 million visitors annually. We're home to Abraham Lincoln. 4 U.S. presidents have an association with the state of Illinois. This year's Hall of Fame inductees and the classes that preceded them, have also earned a place among our state's greatest treasures. Their pioneering innovations and leadership have literally changed the world and are a point of pride not only to us at the University of Illinois, but to everyone who calls Illinois home. Thanks to them, people across the state can brag about that Illinois is a global leader, a true global leader in progress, and then back that up with examples that are ingrained in our everyday life. The Engineering Hall of Fame honors pioneers who gave us LED lighting, handheld calculators, and the transistor, which revolutionized modern electronics. It honors the creative minds behind JPEG digital images, the technology that enabled modern fiber optic communications, and the first graphical web browser that was the forerunner of the World Wide Web. It pays tribute to the inventors of the plasma screen monitors, groundbreaking technology, Plato, and the list continues to go on. It also honors educators who have advanced the never-ending quest for knowledge and innovation, and entrepreneurs who have founded cutting-edge companies that have supplied our high-tech needs, and in the process of doing that, created economic growth for our region, our nation, and literally the world. And today we're proud to enshrine a new class of inductees whose vision, whose passion and commitment have lifted our society and served humanity. Their accomplishments reflect on the core mission of the University of Illinois, our very core reason for existence, to use the power of the academy and the scholarship and the research programs that exist within to create an even better tomorrow, to solve big problems, to find opportunities, a better tomorrow for our state, our nation, and our world. We hope, and I share with Dean Bragg the enthusiasm for telling our story about Illinois and not allowing it to be modestly concealed by our Midwestern culture. We hope people across Illinois and those beyond are as proud of your achievements as we are, and we believe we are. So on behalf of the University of Illinois, congratulations, and more than that, thank you for what you've done for humanity. It's a pleasure to be here.
gently flowing. Illinois, Illinois, by thy prairies verdant growing. Illinois, Illinois, comes an echo on the breeze, rustling through the leafy trees, and its mellow tones are these. Illinois, Illinois, and its mellow tones are these.
It's now my distinct pleasure to introduce our provost, Ilsanami Adisada, or Adi as we all know him. Adi's been a faculty member since 1987. He most recently served as dean of the College of Engineering, and he's been a director as well as the Center for Nanoscale Science and Technology and the Micro Nanotechnology Lab. Adi, the Donald Willard Bigger Willard Professor of Engineering, earned his undergraduate and doctoral degrees at the University of California, Berkeley. Among his numerous honors and affiliations, he's a member of the National Academy of Engineering and chair of the National Science Foundation's Engineering Advisory Committee, and was honored with the Outstanding Alumnus Award from the Department of Electrical and Engineering and Computer Science from the University of California, Berkeley. It's thanks to Provost Adisada that we stand here today. It was his vision and forethought as dean to establish the Engineering at Illinois Hall of Fame in the year 2010. And it's fitting that he joined us today to explain the history and criteria of this event. Adi?
Thank you very much. Good evening. Good evening. That's good. I'm I'm always saluting and expect something back also. Thank you very much. It's as the president said, it's always good to come back to the School of Engineering, to the College of Engineering. So I'm very pleased to come back to the College of Engineering also. The College of Engineering at the University of Illinois at Urbana-Champaign established the Engineering Hall of Fame in 2010, recognizing Illinois engineering alumni and others affiliated with the college who have significant achievements in leadership, entrepreneurship, and innovation of great impact to society. The Engineering at Illinois Hall of Fame creates a timeless tribute to the entrepreneurial spirit and societal impact embodied in engineering education at Illinois dating back to 1870. Each year, the college honors remarkable accomplishments and exceptional individuals by inducting a class of honorees into the Hall of Fame. We celebrate today our third class of honorees. A permanent display will remain in perpetuity in the Granger Engineering Library and Information Center. We invite you to visit the south entrance of the Granger Library and the Granger Gallery on the second floor to see the first phases of our tribute. It is important to recognize and honor these exceptional individuals and the difference they've made and continue to make on our society and the globe. Selection into the Hall of Fame focuses on three primary criteria: leadership, leading a major enterprise in terms of people, budget, resources, outcomes, impact on profession and society. Innovation, a working product, system, or design that has had a positive impact on industry and all society. Something that has changed our lives, a comprehensive body of technical work that has advanced the understanding of the engineering profession. Entrepreneurship, launching an exceptionally successful venture or leading the design of a life-changing product. We are honored today to have a member of last year's Hall of Fame class with us. I'd like to recognize Dr. Bob Liebeck, it's over there, who is a world-renowned leader in aerodynamics, hydrodynamics, and aircraft design and aerospace engineering at Illinois alumnus. With that, it is my great pleasure to introduce Associate Dean Chuck Tucker, who will present the 2012 class of the Engineering at Illinois Hall of Fame for official induction. Thank you.
Chuck? Thank you, Adi. It is indeed my privilege to introduce to all of you the 2012 class of inductees into the Engineering at Illinois Hall of Fame. Honorees will be inducted in alphabetical order. Our first honoree is Mr. Sohaib Abbasi. Sohaib Abbasi completed both his Bachelor of Science and Master of Science degrees in Computer Science at Illinois. He has been Chief Executive Officer of Informatica Corporation since July 2004 and Chairman since March 2005. Under his leadership, Informatica is now the largest independent leader in the data integration software category. Fostering a culture of continuous innovation, Mr. Abbasi has led Informatica into new software market categories, and the company is now acknowledged as a leader in multiple technology categories, including cloud computing data integration, data quality, information lifecycle management, and master data management software. Prior to joining Informatica, Sohaib worked at Oracle Corporation for 20 years, most recently as a member of Oracle's Executive Committee and as Senior Vice President, leading two major divisions, Oracle Tools and Oracle Education. In 1982, he joined Oracle, then an early startup venture with 30 employees. There, he played an instrumental role in growing Oracle's business from $4 million to more than $10 billion in annual revenues. He envisioned and launched the Oracle Tools business, which he grew from zero to nearly $4 billion in cumulative product license revenues. Sohaib Abbasi was named Chairman of the Year as part of the 2010 Annual American Business Awards in recognition of his leadership achievements and contributions. As a strong supporter of education, he has funded an endowed professorship and a fellowship in computer science at the University of Illinois. He and his wife Sarah, who is here with us today, funded the Islamic Studies program at Stanford University with the aim of fostering a better understanding of Islam and Muslims. Mr. Abbasi is a director of the University of Illinois Foundation, and he recently served as the May 2012 commencement speaker for engineering at Illinois. Sohaib, would you please come forward for your official induction? I get to shake your hand. And we're not yet.
Not yet.
All right. Sohaib Abbasi, inducted into the Engineering at Illinois Hall of Fame as technology pioneer and business leader, early employee and innovator at Oracle Corporation, chairman and chief executive officer of Informatica Corporation, an enterprise software category leader. Congratulations, Sohaib.
Thank you. Thank you very much. Thank you, Dean Tucker. When I arrived here from Pakistan, it was the first time I had been to America. I came to study computer science even though I had never seen a computer in my life. I was fascinated by a subject that I knew nothing about. My friends, some of whom are here, and I were at the front lines of the IT revolution. It was the era of punch cards and printouts. I have fond memories of sleepless nights at our DCL waiting for our printouts. I stayed on for my master's, and I had a great title for my master's thesis, Design of Relational Database Operators as an Extension of an Experimental Programming Language. Clearly, the title demonstrated my early marketing skills. Little did I know that it would turn out to be the most important decision of my career. Not long after, I attended my first software show and saw a demonstration of a commercial relational database by a 30-person startup. I applied for and got a job working on exactly what I had studied at Illinois. I stayed there for 20 years. Today, that company is a global market leader called Oracle. In other words, what I learned right here at Illinois directly prepared me for the exciting new field that I have been in ever since. So I am honored and humbled to be here and to share this occasion with these phenomenal engineers. And I will keep striving to give back to Illinois for all that Illinois has given me. Thank you very much.
Thank you, Sohaib. Our next inductee is James V. Barnett II. Jim Barnett first discussed the process for founding a company with fellow Illinois alumnus Ross Freeman during a business trip to Hong Kong in January 1983, after Jim's firsthand experience with 2 Silicon Valley startup companies. 6 months later, Freeman came up with an idea for a new semiconductor product, which Jim also recognized as an architectural breakthrough in programmable logic technology. Their new company, Xilinx, was incorporated and funded on January 9, 1984. Within a month of the founding, the new company had solved technical and cost limitations by going to a static RAM-based volatile technology, similar to microprocessors, instead of non-volatile EEPROM or EEPROM technology used in earlier small programmable logic devices. The Field Programmable Logic Device, or FPLD, was born. The company went public in June 1989, and today Xilinx has 4,000 employees, more than 3,000 patents, 20,000 customers, and revenues of more than $2 billion a year. Jim Barnett holds 3 U.S. patents and is a member of the Band of Angels in Palo Alto, California, the first angel investor organization. He has served on many boards of directors, including Xilinx. Retired from Xilinx, Mr. Barnett now does private venture investing and consulting through Barnett Ventures. Jim Barnett earned his Bachelor of Science degree in ceramic engineering and his Master of Science degree in physics at Illinois. In addition to his awarded degrees, he completed classwork and thesis research for a master's degree in ceramic engineering while at Illinois, and he has since accumulated more than 100 credit hours of coursework at local Silicon Valley colleges. Jim is joined today by his partner, Mary Beth Holman. Jim, please step forward for your induction into the Hall of Fame. Please face the audience first. James V. Barnett II, inducted into the Engineering at Illinois Hall of Fame as innovator in the field of semiconductors, liquid crystal displays, digital watches, pioneered the industry of programmable gate arrays, co-founder of Xilinx, the field programmable gate array creators. Congratulations, Jim.
Of course, I'm here because I named the company after the Illini. Thank you for inducting me into the Engineering Hall of Fame. I am truly honored. It is always nice to come back to campus, especially in the summer and the fall. I am also honored to have my thesis advisor, Dr. Cliff Bergeron, along the aisle back here, in attendance today. Thank you, Dr. Bergeron, and happy fishing. And congratulations to all of my fellow inductees. Our technical education acquired here is the basis of what we have accomplished in the world. It is a strong mix of discipline and technology. Discipline, by the way, is the math and the basic engineering courses. If I could offer future engineers one piece of advice, or maybe a couple, first would be, you have a world-class education, be aggressive with it, use it. It would be, and the advice that I would give you is that it would be to have the courage to think of solutions that are surprising, purposeful, not obvious, and will result in unique opportunities for you and the world. And don't forget the fortitude to defend your ideas. You will need it. I consider my engineering degree from Illinois as a badge of honor. Thank you very much.
We now recognize Preston A. Hinney. After completing his Bachelor of Science degree in Aeronautical and Astronautical Engineering at Illinois, Preston Hinney began his aerospace career at McDonnell Douglas, where he managed several advanced programs in aerodynamics and acoustics for both military and commercial aircraft. He later served as Chief Design Engineer for the MD-80 aircraft. In 1991, he became Vice President and General Manager of the MD-90 program at McDonnell Douglas's Long Beach Douglas Aircraft Facility, where he oversaw the aircraft's complete development and certification process. Joining Gulfstream in 1994, Press Hinney is credited with the design, development, test, and certification of the Gulfstream 5 aircraft, which was awarded the 1997 Collier Trophy. He became a Vice President of General Dynamics in July 1999 when the company acquired Gulfstream. As Senior Vice President of Programs, Engineering and Test, he is responsible for Gulfstream's product management program, engineering, and flight operations. His organization led the development of the Gulfstream 550, which was recognized with the Collier Trophy in 2003, and the Gulfstream 450, and he's leading the development of the new large cabin mid-range G280 and the new ultra-large cabin ultra-long range G650, both of which are in flight test. Mr. Hinney also has responsibility for advanced design and technology development for future product consideration. Preston Hinney is a fellow of the American Institute for Aeronautics and Astronautics and a fellow of the Royal Aeronautical Society. He was elected to the National Academy of Engineering in 2003. In 2005, the College of Engineering recognized Press Hinney with the Alumni Award for Distinguished Service. Among other honors, he was recently inducted as a living legend of aviation by the Kitty Hawk Academy and was presented the AIAA's highest achievement honor, the Reed Award, for his exemplary leadership in the development, design, testing, and certification of major airplane programs and for significant contributions to supersonic boom mitigation. Press is accompanied today by his wife, Connie. Press, please come forward for your official induction. Preston A. Hinney, inducted into the Engineering of Illinois Hall of Fame as Global Leader in New Aircraft Development Programs, introducing advanced technology in aerodynamics, acoustics, avionics, and systems. Congratulations.
Let me thank the university for this wonderful recognition, and Interim Dean Bragg and the distinguished dais we have here, thank you very much, and congratulations also to the other honorees here. I'm certainly honored and humbled to be recognized in the Engineering Hall of Fame at Illinois. It's been over 40 years since I walked the quad and walked classes around the university. It has changed immensely over those 40 years. As an undergraduate student in aeronautical and astronautical engineering, it was part of my dream to be at Illinois. And that stemmed back from my very early days. I was always an aircraft guy. As a kid, I built model airplanes, incessantly flying them. My dad watched this and he said, you know, at some point you ought to be an aeronautical engineer. I thought about that and said, gee, that sounds pretty cool. I'm not sure I can spell it, but it sounded really neat. I came to the University of Illinois during some high school trips and concluded they had a great school of engineering and had an aeronautical and astronautical engineering department. I came to Illinois and I haven't looked back. It was here that I really got the passion for aeronautical engineering. It provided the basis, the foundation for me to go forward. You heard about a tour at McDonnell Douglas. I was at McDonnell Douglas for 25 years. Had a great career, and the basis for that was the education here at Illinois. I then went on to Gulfstream. I'm still at Gulfstream, continuing on at Gulfstream, as you've heard. Again, the basis really stems all the way back to the foundation formed here at Illinois. I've been lucky to be a part of a number of teams, and that's really why I'm here. The success I've had really is due to the success of some brilliant teams that I've been lucky to be a part of. Those teams succeeded, that allowed me to succeed. In the aircraft business, it's really not one person. It's a tremendous team of individuals that can design, develop, and certify a new flying machine. And so my success is really due to those teams. I've been at the executive level now for a number of years. And what does that mean? That means you're in a position now where you're responsible for the well-being and the future of literally thousands of people. With that, it's a very sobering thought to realize that the decisions you make really does lead your organization in some direction, and all of their future depends upon how well you do. It's a very sobering part of a career growth pattern. And so, again, I trace my ability to have been successful, some to luck and some to the education here at Illinois. While I have been at the executive level, I have to confess, my heart is still in engineering, my heart is still in aeronautical engineering, my heart is still an aerodynamicist. I still carry the technical curiosity in aerodynamics where I started. And again, that's traced back to my time here at Illinois. Thank you for this wonderful honor. I certainly appreciate it.
Our next inductee is Charles H. Henry. Dr. Charles Henry completed his PhD in physics at Illinois. His work in semiconductor physics research in optoelectronics at Bell Laboratories spanned 33 years and is noteworthy both for its innovation and insight as well as for its breadth. His accomplishments bridge the gap between physics and engineering and demonstrate a rare mastery of both theory and experiment. Dr. Henry spent his entire career at Bell Labs working on LEDs, semiconductor lasers, and integrated optical circuits. In his early studies of Raman scattering and photoluminescence, Henry was the first to experimentally observe polaritons. An important early result was identifying the source of the red light emission in gallium phosphide LEDs, an exciton bound to a nearest neighbor donor-acceptor pair involving the deep donor oxygen. Dr. Henry went on to studies of catastrophic damage, mode partition noise, spontaneous emission noise, and quantum noise in photonics. As head of the Semiconductor Electronics Research Department at Bell Labs in the early 1970s, his modified laser structure would result in a semiconductor laser with improved performance, allowing very high quantum efficiencies. He also realized that the laser wavelength could be changed merely by changing the thickness of the thin quantum well layers. He received a patent for this invention, which came to be called the quantum well laser. Dr. Henry is also well known for his work introducing MLAX's alpha parameter into semiconductor laser physics, which Henry used to explain the observed wide line width of these lasers. His groundbreaking work is frequently cited due to the importance of this parameter, now known as the Henry line width enhancement factor, in determining the line broadening and frequency modulation of semiconductor lasers. An important aspect of Charles Henry's work in the early 1980s was his role in developing a new way of making integrated optical circuits, which came to be known as silicon optical bench waveguide technology. This technology came to be widely used in fiber optic telecommunications. Retired from Bell Labs as a distinguished member of the technical staff in 1997, Charles Henry has 133 published papers and 27 patents. He is a fellow of the American Physical Society, the IEEE, and the American Association for the Advancement of Science. Among his many other honors are the Alumni Award for Distinguished Service from the College of Engineering and the American Institute of Physics Industrial Applications of Physics Prize. Dr. Henry's wife, Helene Henry, is here today joining us for the Hall of Fame celebrations. Dr. Henry, congratulations. Charles H. Henry, inducted into the Engineering at Illinois Hall of Fame as the inventor of the quantum well laser, who also introduced the Henry line width enhancement factor to explain the significant line broadening of semiconductor lasers.
Thank you very much. I'm deeply honored to receive this award. It is something I never expected or dreamed of. When I came to Illinois as a graduate student in physics, I was torn between choosing to work in theory or experiment. I was always interested in understanding physical theory, but I worried that I didn't have the hands-on experience to do experimental work. Fortunately, I learned to work with my hands in a course in electronics taught by Professor David Lazarus, and by building a microwave spectrometer as a thesis student of Professor Charles Slichter, who's here this evening. I'm very grateful to Charlie for all the encouragement and support he has given me over the years, and especially for his friendship. I left Illinois having the benefit of great teachers and a great advisor. I had a doctoral degree, a lovely wife, 2 children, no money, but a job offer to work in research at Bell Laboratories in Murray Hill, New Jersey. Bell Labs was perfect for me. It gave me many opportunities to make contributions in the field of optical fiber communications, where the light sources are semiconductor lasers. There were many problems to be solved in this area, and I was privileged to work on them. Whatever I accomplished as a physicist was made possible by the wonderful education that I received here in the Department of Physics. On a personal note, I would like to mention that I was the first in my family to go to college. Neither of my parents finished high school, but they always encouraged me in my studies. My mother would ask me if what I was doing would help mankind. I don't know about mankind, but I do know she would be very happy to see me here today. Thank you very much. Head off here.
Back to your seat. Our next honoree is Carl J. Johnson. When Carl Johnson completed his PhD in electrical engineering at Illinois, he knew that the fledgling CO2 laser industry was in need of something better than sodium chloride, that is table salt, for use in the infrared lenses, windows, mirrors, and beam splitters. This industry needed something that would enable laser powers to evolve from a few hundred watts to the multi-kilowatt level that would enable large-scale industrial deployment. A few years later, that idea culminated in the founding of II-VI Incorporated. II-VI Incorporated, which literally started with two guys in a garage having no equipment, no products, no customers, and no sales, has steadily grown into a public company having thousands of customers worldwide, over 6,000 employees at 27 locations in 13 countries, and annual sales greater than $500 million. The core capabilities upon which the company has been built include the crystal growth of II-VI compound semiconductors and other laser, optical, or electronic materials, and the fabrication and finishing of reliable, affordable, high-technology parts for which there is worldwide commercial demand. Johnson served as the company's principal executive officer for 36 years. Since his retirement as an employee in 2010, he has continued as chairman of the board, and he has served the company and its 8 business units in various advisory roles. Dr. Johnson and his wife Margot, with us for today's ceremony, are the founders and financial contributors to 2 charitable foundations. The II-VI Foundation, with its mission to identify talented young people having a propensity for science, mathematics, and technology, and to nurture and support them in the pursuit of an engineering or science education through their BS, MS, or PhD experiences. And the Johnson Foundation, with its commitment to high-value educational, cultural, and Christian mission initiatives and projects. Carl Johnson credits his interest in laser technology in part to the culmination of his laser-based education in Professor Paul Coleman's lab, the Electrophysics Laboratory here at Illinois. Important to his preparation for a career in technology-based business, Dr. Johnson served as a member of technical staff at the Bell Telephone Laboratories for 2 years and as the coordinator of research and development for Essex International, later a division of United Technologies, for 5 years. Carl, would you please come forward for your Hall of Fame induction? Carl J. Johnson, inducted into the Engineering at Illinois Hall of Fame as entrepreneur and co-founder, chairman, director, and former CEO of II-VI Incorporated, innovator in infrared optical materials and the growth of II-VI compound semiconductor crystals and other optical, laser, and electronic materials. Congratulations.
Chancellor Wise, President Easter, Provost Adeseda, Dean Bragg, and Associate Dean Tucker. Thank you so much for selecting me and my classmates for this year's Engineering Hall of Fame. It is a great honor, and I think we're all very happy to be here to share our story, our insights, hopefully to serve as an example and a role model for future students here at Illinois. I am very interested in sharing with you some of the key things that I've learned along the way, and today I want to feature in my comments two things that have been extremely important to my lifelong learning process. And it has to do with who I have learned from so much over the years. And there are really two groups: peers and contemporaries, who are, of course, the colleagues of mine who are at approximately the same stage of life, and we struggle together to make it through different trials. But maybe more importantly, to the mentors that I've had during my life, who are a half a generation to 2 generations ahead, and are often very eager to share their experience and help us along, and maybe to save us some pain along the way. The best example I can give you of a contemporary is a lady who is very caring, very loving, very supportive, and I must say, very wise. My wife, Margot. Thank you, Margot. And during my growth and my success in my career, mentors have been extremely important. And that started very early in my life, and I've been blessed with many. And my mother and father, for instance, taught me that anything worth doing is worth doing to the best of my ability. Pastor Tonsing at the First Lutheran Church in Topeka, Kansas, helped me to establish a spiritual cornerstone to my life, and helped me to complete my Boy Scout God and Country Award. My high school teachers, Marjorie French and Hubert Ellithorpe, showed me that math and chemistry were so much fun that it absolutely compelled me to go off and become an engineer. But then there was a difficult and almost unexplainable hiatus in my learning from mentors between the ages of 18 and 24. And I now know that that's because, and of course none of you have ever been there, but during this period of my life, I decided I didn't have to listen to anybody. So no wonder I didn't have any mentors during that period. But that all ended one day in September in 1966 when I walked into the laboratory of Professor Paul Coleman here at the University of Illinois. And I was really excited to see lasers 30 feet long, 6 inches in diameter, that were pulsing and giving out energy. And it was exciting to see lasers of that type at that time, 1966. And I went into Paul's office and met with him and said, I'm not so excited about the laser itself, but why don't we take what's coming out of the laser and shoot it at some materials and see what happens and see how those materials interact with what is known as far infrared radiation. And that would be radiation beyond 15 microns in the infrared, pretty far out in the infrared. I think Paul intentionally chose to work in this region because the problems there were very difficult and challenging to his students. But he agreed that that was a pretty good idea. And really, the rest of the students were working on the lasers and why they worked and how they worked. And more or less, along with Paul, I pioneered the idea of looking at materials using these light sources in the far infrared. And I must say that I enjoyed working on the difficult problems that Paul gave me, and I want to just describe one of them. When we successfully, we were going to modulate the output of a 28 micron water vapor laser. And modulate means think of it as turning it on and off by applying some excitation to a crystal. And it turns out that could be done at room temperature. And it only took maybe 5 or 6 months to get that experiment to work. And I went into Paul's office and said, "We got it done. Does that mean I'm finished?" And Paul said, "No, I think we've got a nice strong line at 118 microns. And in order to get that energy through the crystal, we're going to have to cool the crystal to liquid helium temperature and then put the voltage on it and see if we can measure and affect the switching phenomena." And that turned out to be a very difficult experiment. Paul, I think you would agree that was kind of a challenge. And I remember the biggest part was getting the light into the liquid helium dewar and then getting it back out. And I remember telling Paul there was only one window material in the world that would work for that experiment. And that was type 2A diamond single crystals. And when I told Paul how much they were going to cost, he almost decided to cancel the experiment. But he didn't. And when we were done, I'm sure Paul sold those diamonds on the open market and got it. Later in my business career, as I developed as a business person, I had 4 additional mentors. And that comes to a total of 10 that I've been able to look back on, and I owe them so much. And Paul, I owe you so much, but because it was you and the University of Illinois that put a laser technology imprint onto my mind and my being and caused me to go forward and help the laser industry to grow and mature and do a lot of very interesting and great things for the world. So to each of you, to Uncle Paul, and to the University of Illinois, I say thank you very, very much.
We now honor Stephen B. Sample. Dr. Stephen Sample earned his Bachelor of Science degree, Master of Science degree, and PhD in electrical engineering at Illinois. Under Stephen Sample's leadership as president of the University of Southern California from 1991 to 2010, USC solidified its status as one of the nation's leading research universities and emerged as a world leader in the fields of communication, multimedia technologies, and life sciences. Dr. Sample made breadth with depth the hallmark of undergraduate education at USC, encouraging all students to develop the kind of intellectual flexibility displayed by the best thinkers of the Renaissance. Stephen Sample came to USC from the State University of New York at Buffalo, where under his presidency, that institution achieved standing as a member of the Association of American Universities. A tenured professor at the USC Viterbi School of Engineering, Dr. Sample has been awarded USC's highest faculty honor, the rank of University Professor, in recognition of his achievements. He is a member of the National Academy of Engineering and of the American Academy of Arts and Sciences, and the author of numerous journal articles and papers in both science and engineering and higher education. His patents in the field of digital appliance controls have been licensed to practically every major manufacturer of appliance controls and microwave ovens in the world. Dr. Sample is a past chair of the Association of American Universities and has also chaired a number of state and national groups examining the status of elementary, secondary, and higher education. In 1994, he convened a group of Los Angeles leaders who were awarded a historic $53 million challenge grant from the Annenberg Foundation to accelerate reforms in local public schools. To capitalize on the emerging prominence of the Pacific Rim, Sample co-founded the Association of Pacific Rim Universities, a consortium of 42 premier Pacific Rim research universities located in 15 countries that fosters international collaboration among faculty, students, and university leaders. Dr. Sample has received several honorary doctorates and numerous awards for his contribution to higher education, engineering, and the nation. His awards include the IEEE Founders Medal, the Chancellor Charles P. Norton Medal, which is the highest award bestowed at SUNY Buffalo, the Humanitarian Award from the National Conference of Christians and Jews, and the Distinguished Alumni Award from the College of Engineering at Illinois. In April of 2011, USC presented Sample with its highest honor, the Presidential Medallion. Stephen and Catherine Sample Hall at USC is named in honor of Sample and his wife, the former Catherine Brunkow of Park Ridge, Illinois. In addition, Sample and his wife established the Renaissance Scholars Endowment, which supports juniors and seniors at USC who excel in widely disparate fields of study. Sample's best-selling book, The Contrarian's Guide to Leadership, has been translated into 6 languages. Its royalties fund scholarships for USC undergraduates. Dr. Sample is joined today by his wife, Catherine, daughter Michelle Smith, and granddaughter Catherine Smith. Stephen, would you please join me at the podium? Congratulations. Stephen B. Sample, inducted into the Engineering at Illinois Hall of Fame as Innovative Leader in Higher Education, Model Administrator, Teacher, and Researcher, Award-winning Scientist, and Inventor of Digital Appliance Controls used in appliances and microwave ovens worldwide. Congratulations.
I have just one question for all these good people that have given me this wonderful honor. And that question is, have you ever heard of honors being handed out in reverse, alphabetical order? I mean, what the hell, isn't it time to, for a little equity here? I've heard of awards being given on the basis of random access. Generally, though, it's alphabetical order as it was here. So I just want to file out one small complaint. The other thing I'd like to say is that in addition to honoring people, which of course is the most important thing, we honor human beings, our colleagues, our friends, our family, and whatnot. We also honor principles. Undergirding principles, if you will, that withstand the test of time. Principles that will outlast all of us, all of our progeny, but the principles themselves can continue as bedrocks for our society. I'm reminded of a story which my wife says I shouldn't tell. It's not that kind of story. But in any event, it's a story from which I learned a principle. And the principle is, any academician is worth 10 times more than any administrator. And that's a little rough, isn't it? A little harsh, but it might actually be true. And I tell that story because Mac Van Valkenburg was my principal mentor all throughout my life, both personally and professionally. And I learned so much from Mac, and that was one of the things I did learn from Mac. Administrators aren't all that important. and I learned that principle through an experience. When I got my bachelor's degree, I had won 2 fellowships, a Ford Foundation Fellowship and a National Science Foundation Fellowship. The peculiar reality was that if I accepted
the Ford Foundation Fellowship, the university would lose the National Science Foundation Fellowship. It would go to some other university. Whereupon, if I accepted the National Science Foundation Fellowship, the university would not lose the Ford Foundation Fellowship. So you can see what the university wanted me to do. And of course, what the university wanted me to do was to take on the National Science Foundation Fellowship. That would be good for the university. And I was called into the office of an assistant dean, for God's sake. Can you imagine that? An assistant dean of the graduate school. And this guy tried for a long time to talk me into taking the less money approach, the approach that could be transferred to another school. And so he finally leaned across his desk and he said, you know, Sample, he said, we can work it out so that you got nothing. That's called threatening. We can work it out so that you got nothing at all. Think about that for a while. I went home and I was so dispirited. I said, there's nothing to do. We had no family wealth. We had no family standing of any kind. And my wife said, call Mac Van Valkenburg. I said, honey, what the hell would Mac Van Valkenburg know about politics like this? She said, I think Mac could help you out. So sure enough, I called Mac, told him the whole story. He said, guys, see, that's a wonderful story. He said, I'll bet you I can fix it, though. And from there, that's when I first learned how important senior faculty are as opposed to bureaucratic. So all of that being said, and my wife now is a little upset with me, I'm sure. Let me thank you for this honor. I don't deserve it, but that's all right. I don't deserve most of the honors I've got. I want to thank you for the honor. Thank you on behalf of all my colleagues for the honor. And just say it's great to be an Illini.
Next, we recognize a posthumous award, M.E. Mac Van Valkenburg. I feel like Mac's already been introduced. Although he was recognized throughout his career for achievements in circuit theory, beacon antennas, servo mechanisms, and computer science, Mac E. Van Valkenburg was even more renowned for his commitment to engineering education and for his textbooks. At his memorial service in 1997, Dr. Stephen Sample remarked, Mac Van Valkenburg was, first and foremost, a teacher par excellence, one of the very best engineering teachers in the world. After graduating from the University of Utah in 1943, Mac's involvement in the war effort led him to MIT's Radiation Laboratory, where, under the direction of Ernst Guillemon, he helped develop radar. After earning his master's degree from MIT in 1946, he taught at the University of Utah until 1955, with 2 years off to complete a PhD at Stanford. In 1955, Dr. Van Valkenburg came to the University of Illinois as a member of the electrical engineering faculty and as associate director of the Coordinated Science Laboratory. He was one of the organizers of the first Allerton Conference on Circuits and Systems in 1963, which grew to be one of the premier conferences on systems theory. In 1966, Dr. Van Valkenburg went to Princeton as head of its electrical engineering department. In 1974, he returned to the University of Illinois, and in 1982, he received the first endowed chair in the College of Engineering, the W.W. Granger Chair in Electrical Engineering. He served as dean of the College of Engineering at Illinois from 1984 until his retirement in 1988. Mac Van Valkenburg may be best remembered for his seminal engineering textbooks, books that were hailed by colleagues and students as models of clarity and engineering classics. Network Analysis, first released in 1955, had a major impact on engineering education. In 1960, Introduction to Modern Network Synthesis was published, followed by Analog Filter Design in 1982. A member of the National Academy of Engineering and a fellow of IEEE, Dr. Van Valkenburg received numerous awards and honors for his efforts in engineering education, including the Halliburton Engineering Education Leadership Award, the IEEE Education Medal, the American Society for Engineering Education's Lamé Medal, ASEE's highest honor, the ASEE George Westinghouse Award, the IEEE Centennial Medal, the Guilliman Prize, and Distinguished Alumni Awards from the University of Utah and the University of Illinois. The IEEE Education Society annually awards its Mac Van Valkenburg Award to young faculty members who have made outstanding contributions to teaching early in their professional careers. We are especially pleased to have with us today Dr. Van Valkenburg's son, David, and his grandson, Albert Van Valkenburg. David, would you please come forward at this time to accept this honor on your father's behalf? Just give Albert a minute here. Right over here. Okay, thanks. M.E. Mac Van Valkenburg, inducted into the Engineering at Illinois Hall of Fame as Distinguished Engineering Educator and author of internationally renowned textbooks. As Engineering Dean, he led the College of Engineering to international eminence during a time of great growth and innovation within the college.
I need that photo for Albert's application to the College of Engineering at Illinois in 7 years. My father was an engineer, but he really always thought of himself as a teacher. And over the years at Utah, Princeton, and here, he had many thousands of undergraduate students, and he reached many other students through the 7 textbooks. I don't know how many additional students that would be, but once when we were discussing college finances and he was urging me to do whatever was best for my education, no matter what it cost, he says, "You know, David, I just sold my 1 millionth copy of my favorite textbook. So let's not discuss what it costs." And so his undergraduates, his students at other universities who learned from him indirectly, and his graduate students, and a couple dozen people that he referred to as his PhD candidates, who he referred to as his academic children. For example, Dr. Sample, who I've known for a very long time because of that connection, and others. And when he called them his academic children, I sometimes got a little jealous. But besides teaching engineering, he could really teach anything. For example, any high school math or science class, if I got stuck, perhaps because I let my teacher down or perhaps because my teacher let me down, he could pick up on a dime and go from that spot to where I needed to be, without reviewing. And he could teach other things too. I left high school. I went to Stanford because he went there, I guess. And I studied linguistics. And he could help me with that too, because he could say, well, David, a complex project can always be broken down into a series of less complex tasks. And any project, any program will benefit by some advanced planning and organization. And this also carried into my diplomatic career. Really, he was my teacher for his entire life. One disappointment I think he had is that of his 6 children, none of us pursued anything remotely related to engineering. A psychiatrist, some journalists, service in government, and my own case, diplomatic service for representing the United States abroad. I occasionally use some statistics, and my brother, the psychiatrist, occasionally uses a little biochemistry, but that's as close as any of us got to engineering. And because he never pushed us in any particular direction. He was perhaps disappointed that we didn't go into engineering, but he never told us what we had to do. He was always supportive. I mentioned the financial and I mentioned the tutoring, but he was always supportive, but he was never directive. So 6 children, no engineers. 12 grandchildren, 1 engineer, which is why Albert came here with me today. Having completely skipped a generation, Albert is one of those kids that scores perfect papers on nationwide or statewide math and science exams, and whose idea of fun is programming a computer to control a robot. And that's why he had to come do his pre-application campus tour. So Albert gets a few advantages as a result of my father's elevating our family a bit. I'd just like to finish by one-upping a previous speaker. My father was the first in his family to attend high school. And we're trying to put every opportunity in Albert's way, but some people don't. Some people succeed without those opportunities. And thank you.
Our final honoree, M.T. Jeffrey Ye, was not able to travel to campus today, but we honor his accomplishments nonetheless. M.T. Jeffrey Ye has made significant and lasting contributions to the construction and financial sectors in Hong Kong, serving as chair of the Sin Chong Group of companies, including the Sin Chong Construction Group Limited, a publicly listed company until his retirement in 2002. He is the current chair of the Sin Chong International Holdings Limited. After completing his Bachelor of Science degree in Civil Engineering at Illinois and earning a master's degree from Harvard University, in 1955, Jeffrey Ye joined Sin Chong and Company in Hong Kong, the construction company founded by his late father, Mr. K.N. Godfrey Ye. Jeffrey Ye's commitment to community service is reflected in his membership on Hong Kong's Town Planning Board from 1976 to 1984. He also chaired the Construction Industries Training Authority from 1975 to 1987 and served as a member of the Consultative Committee on the New Airport and related projects from 1995 to 1998. He was a longtime council member and past president of the Society of Builders and was a member and officer in the Building Contractors Association. In 1991, Ye became an independent director of Hong Kong Futures Exchange Limited, and in 1993 he became vice chairman, ultimately chairing the exchange from 1998 to 2000. He was also a director of HKFE Clearing Corp. From 1998 to 2000. As a founding court member of the Hong Kong University of Science and Technology, Ye took a leading role in university governance, serving actively until 2004. He was also a court member of Hong Kong Baptist University from 1995 to 2001. In 1976, Ye was appointed a Justice of the Peace, and in 1981 to the Most Excellent Order of the British Empire. In 1982, he received an honorary doctorate degree in commercial science from St. John's University in New York. In 2000, he was conferred the Silver Bauhinia Star by the government of the Hong Kong Special Administrative Region of the People's Republic of China. He also served as the Honorable Consul of Jamaica in Hong Kong from 1984 to 2002, and in 2003 was awarded the Badge of Honor for Meritorious Services by His Excellency the Governor General of Jamaica. Ye founded the Ye Family Philanthropy, a family foundation, in 2011. A member of the President's Council of the University of Illinois Foundation, Jeffrey Ye was the lead donor for the M.T. Jeffrey Ye Student Center, a 20,000-plus square foot addition to the Newmark Civil Engineering Laboratory. The Ye Center provides state-of-the-art classrooms, meeting rooms, and informal gathering space for students in the Department of Civil and Environmental Engineering at Illinois. So we now induct M.T. Jeffrey Ye, inducted into the Engineering at Illinois Hall of Fame as entrepreneurial leader, global philanthropist, founder, and retired chairman of Sin Chong Construction Group Limited. Please join me in recognizing the accomplishments of M.T. Jeffrey Ye. Dean Bragg.
Thank you, Chuck. I'd like to add, again, my congratulations to all the Hall of Fame inductees, and wonder if we could give them all another round of applause. I'd also like to thank President Eetzer, Chancellor Wise, Provost Adishita for joining us today. I'd like to thank Associate Dean Tucker for all his work, Associate Dean Molly Tracy, Angie Dimmitt, John Kelly, and many other people, university people who've helped do this, the families, certainly thank you for all attending. This concludes our formal ceremony here. If the awardees and family and others could stay for pictures. For the rest, there's a reception in the atrium, and we'll join you just as soon as we can after a few more pictures. So thank you very much for coming.